Hello and welcome to T3, Day 3 of Honors Precalculus. Today we're going to talk about parabolas, which we're going to kick off by trying to find an equation for the set of all points that are equidistant from the point 0, 1 and the line y equals -1. We're going to do this by setting up a distance equation. The first one is going to look like this: x minus 0 squared plus y minus 1 squared. And the reason we're going to do that is we're calculating two distances and setting them equal to each other. So for example, let's say this point xy, first we have 0, 1 right there, and then we have this line y equals -1 down here, and we have some point off in space right here. That is the point, one of the points we're trying to find. We're calling it xy. So what we're doing first is we're going to call this one distance 1, and this distance right here is the straight line distance. We'll call it distance 2 right there, distance 1 and distance 2. So this distance right here, distance 1, is the distance from the point to 0, 1. So if we wanted to find, and I'll use that a different color down here, if we wanted to find this distance, this straight down, that distance 2 is going to be the square root of x minus x squared, because it's going straight up and down, it's a vertical line, and y plus 1 squared. So when you do distance 2, it's always the straight line distance. It's perpendicular right there, but this one necessarily, this d1 necessarily is not necessarily the same. So these two things are supposed to be the same. So that means that the square root of this one, x minus 0 squared plus y minus 1 squared, is going to be the same as distance 2, which is x minus x squared, so 0 squared, plus y plus 1 squared. And when you simplify this, what do you end up with? You end up with x squared plus y minus 1 squared equals y plus 1 squared. I just squared both sides right there. You multiply this out, you get x squared plus y squared minus 2y plus 1 is equal to y squared plus 2y plus 1. What you end up with is the 1's canceling right there, and then you also end up with the y squareds canceling right there. So you end up with x squared equals 4y. So y is equal to 1/4 x squared, and that actually is, as we know, a parabola. It's pretty cool. So when you did this out, 1/4 x squared, what are you actually gonna get? You're gonna get a function 1/4 x squared. It kind of goes like this. It goes like this on both sides. It's kind of cool. It's not exact, but it's pretty close. So a parabola is the set of all points whose distances from the given line, the directrix, the given line, the directrix, and the given point focus are equal. A focal length, the focal length is the directed length from the vertex to the focus. So that's the straight line distance. The focal width is the length of the chord through the focus and perpendicular to the axis of symmetry. And all of that looks like this. You have the focus in the middle of the parabola, which is in red, and then the focus length is this green distance right here. That focus length is that green distance. And then the focus width is this entire distance through the focus across. And then the directrix is the line that is part of the definition here down here. So this one just says, find an equation for the set of all points that are equidistant from the point 0p and the line y equals -p. So this is exactly what we did before, but we're just using p instead of some numbers here. So what that means, just generally speaking, is we have this line right here, y equals -p, y equals -p. We have some point out here. We have maybe 0, 1. Remember, it doesn't have to be a right angle, but it does need to be a right angle there. You have distance 1 and distance 2. I'll make that a d, so it actually looks like a d right there. So how do you figure this out? Well, this one is xy. Remember, this distance right here is straight up and down. This one does not have to be straight up and down. So distance 1 is going to be the square root of x squared plus y minus p squared, very similar to what we had above, just with p instead of numbers. And then below it we end up with, because it's straight up and down, x minus x squared. You're not moving anywhere xy's on that line, plus y plus p squared right there. So what's that going to be? You set them equal to each other and you square both sides. So you end up with x squared plus y minus p squared is equal to y plus p squared, like this. Similar to what we did before. When you multiply this out, you end up with x squared minus, x squared, well, plus y squared minus 2, it's a minus sign, not an equal, minus 2yp plus p squared is equal to y squared plus 2yp plus plus p squared. Similar to what we did before, the p squareds cancel. I think those were 1s before, and these y squareds cancel. So what are you left with? X squared minus 2yp is equal to 2yp. So you end up with x squared is equal to 4yp. So what does that mean? You end up with y is equal to 1 over 4p times x squared. That's very similar to what we had before with a number for p instead, which I think was 1. We can. So how does that help us? Well, it means we can generalize here, because now that tells us that p is the focal length. Focal length. That is the focal length. And remember, the focal length is right here. That's the focal length. So you can be told the focal length now instead of other information. So to summarize, we have everything here about parabolas. Very, 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 very important. So let's find an equation for the parabola given the focus. So that's what the parabolas are on, in the directrix of 1. So what that tells us, we can just fill this in. We know that it's going to be y minus k is equal to 1 over 4p times x minus h squared. And then we can use all of these right here. So that tells us that the k value here is something we should sketch out to find. So when we sketch this out, we end up with first the directrix, which is y equals 1. That's the line you have to be distant from. Next, we know the focus is at 5, 4 right there. So what that tells us is the vertex is going to be somewhere in between. So this parabola, just to remember, is going to go something like this right here. It's going to go something like that. That's the focus. So we need to find this vertex right there. The first thing we know is that the vertex is going to be on x equals 5. It's on the same thing as the focus right here. So we know that the vertex, which is somewhere there, not that point, sorry, is going to be somewhere on the line x equals 5. So it's going to be 5, comma, and the key thing to realize here is that the distance from the focus to the point, so the focus to the point here, has to be the same as going straight down. So what that means is that this distance right here has to be the same as this distance right there. So what that means is that this point right there, the k value is going to be the average between the height of 1 and 4. So k is going to be equal to 4 plus 1 over 2, which is 2.5. So in this case, our vertex is going to be 5, 2.5. That's right there. It's halfway between. So what that means is we now can plug in a lot of material here. We know y minus the k value is 2.5, equals 1 over 4p, x minus the h value of 5 right there. And we're going to square that. And now we just need p. And p is equal to the focal width. So how do we do that? Well, the one thing we have here is that the directrix, y is equal to k minus p. So y is equal to k minus p. And we know that's 1 because it's this line right here, y equals 1, equals the k value, which is 2.5 minus p. So p is going to be equal to 1.5. So what this means is that we end up with y minus 2.5 is equal to 1 over 4 times 1.5, x minus 5 squared. That's our final answer. Now, just to recap here, we had to find first where the vertex was, and we knew it has to be on the same x value, which is 5, of the focus. And then we know the vertex has to be halfway between the focus and the directrix, so that's how we got the 2.5. Then we plugged it in, and that allowed us to find the p-value and then finish. So the key to sketching these graphs by hand, which you've kind of done before but not like this, is you can put it into the format we had above. So if you take this right here and put it into the format from above, what do you end up with? You end up with y plus 4 is equal to 1 over 2 times x plus 2 squared. So what that means is k, here's our k value right here, it's y minus k. So that means that k is going to be equal to negative 4 here. And then we know that it's x minus h, so h is equal to negative 2 right there because it's plus 2, has to be the minus of it, right? And then we know that 1 over 2 is equal to 1 over 4p. So that means that p is going to be equal to a half. So with all of these pieces of information right here, k equals negative 4, h equals negative 1, and p is equal to a half, you can scroll up here and take a look at everything that's been communicated to you right here. We now know that the vertex is hk, where the directrix is k minus p, and where the focus, focal length, and focal width. And you can use all of that information to sketch this. I leave you to do that on your own. So do that on your own, maybe pause here, but you can unpause and just remember that you can use all of the information above, which I put right there. So the vertex is going to be -2, -4, which I plotted right above. The directrix is going to be y equals k, and that's going to be the -4 minus p right there. So you know that p is equal to, what is it, a half right there, so -4 minus that, so it's going to be equal to y equals -4.5 right there. So there is your directrix right there. So -4.5 is right in the middle there, y equals -4.5. And then your focus on this is going to be h, which we know is going to be -2, k plus p, right there, k plus p. So when you add k and p together, you get -3.5. It's halfway up there. So the focus is going to be -3.5, which is going to be right there. So there's your focus right there, your focus. So then what else do you have here? Let's list it out here. You've got the focal length, which is p, and then the focal width. So when you do this out, you can also plot intercepts. Those are very good to plot, and that's just when x is 0 and y is 0. So when x is 0, you end up with 2 squared over 2, so 4 over 2. So you end up with, so when you plug in 0, you get -2. It's going to be symmetric, so it's going to be right over here as well. So then when you graph this, you're going to end up with something that looks just like this. So you could do the x-intercepts, and that's when y is 0. So 0 is equal to 1/2 of x plus 2 squared minus 4. So 4 is equal to 1/2 of x plus 2 squared. So 8 is equal to x plus 2 squared. So you get x plus 2 is equal to plus or minus the square root of 8. So x is equal to -2 plus or minus the square root of 8. You need that's going to be the distance from here to here. So that's plus or minus the square root of 8 right there. But that would be a great graph just like that. So just to recap, the thing you really got to know is right there. Super important, right there.